Okay, so we're going to take a look at motion in a horizontal circle. One of the easiest ways to generate motion in a horizontal circle is called the conical pendulum. An object is suspended by a cord and then projected sideways, and it starts to describe a horizontal circle. So I've just stopped it in this position just so that we can talk about some of the misconceptions. Firstly, this tension and this weight are the only forces acting on this object. Lots of people put a third force pointing towards the center here, but it is really coming from the other two forces. So when you're asked to draw a free body diagram, you only draw the forces that are actually on the object. What happens is that these two give a resultant that points this way, but you can't include the resultant and the forces that cause it on a free body diagram. So I've just stopped it in this position so we can look at a couple of the misconceptions that people have about this kind of motion. And firstly, this object isn't rising or falling, it's staying at the exact same position in the vertical direction. So we do have vertical equilibrium here, and the vertical component of the tension, the thing that's trying to pull it in this direction, is being balanced by the weight of the object. Those two are in equilibrium. Now we can write an equation for that and say that t cos theta is going to equal mg. And that's really like applying Newton's first law. There's vertical equilibrium, therefore the upward and downward forces must be in balance. Main problems here arise when people try and describe what's happening in the horizontal direction here. And you often see people writing an outward force that's then being balanced by the horizontal component of t. So you would sometimes see people writing something like this. Okay, now the problem is that that is complete nonsense, because that is implying that there's horizontal equilibrium between two different forces. And the first thing is, this force doesn't exist. There is no mysterious mv squared over r force which turns up when objects move in a circle. This is not Newton's first law. It's not equilibrium. What's happening here is that there's an imbalance pointing this way. So we're really writing F equals ma. The imbalanced resultant force pointing this way is equal to ma. So this is complete nonsense. Now it doesn't change the equation. It just changes what it means. What's happening here is that we have a resultant force that way, t sine theta, and this thing on the right tells us its value. So this is F equals ma that we're actually writing down here. So it's really Newton's second law that we're writing in the horizontal direction. So we still end up with two equations, but one of them is based on a balance of forces, and the other one is based on there being no balance in forces. There's being a resultant force towards the center. And mv squared over r is not an opposing force, it's the value of t sine theta. In any case, if you divide equation 2 by equation 1, then the left hand sides you get t sine theta over t cos theta. The t's will cancel, and sine theta over cos theta will combine to give you the tan of theta. And then you need to divide the right hand sides. And so you get mv squared over r divided by mg, which gives you v squared over gr. And this result is a fairly common thing that you would be asked to find in cases where you're dealing with a conical pendulum. And the other thing to remember here is that the sine theta, cos theta and tan theta will relate to the properties of the triangle that the system makes. So the height will have a relationship with r, and there'll be a relationship between the length of the chord and the other two. And so in each case you should be able to write out sine theta, cos theta and tan theta relating to L and H and R. Okay. So hopefully that's given you an introduction to how to solve and work on these problems. So just to summarise, you have a set of equations you can put together that relate to the physics of the situation, and then you have another set of equations that you can formulate that relate to the geometry of the situation. Now obviously some books may put theta down here, marking it to the horizontal, and that will reverse a lot of your trig functions. Your sines and causes will swap over, and your tan will be h over r instead of r over h. So you need to just bear that in mind. These equations are based on theta being up here, the angle between the string and the vertical. So just bear that in mind when you're using them, that they're not just plug-in, you have to base it on the particular way the situation has been described to you. Okay.